Hi everyone. I guess you're ready already for today's lesson. Just make sure you have your graph sheet, your pencil, and um, possibly your notebooks by your side so we can get started. In our previous lesson, we discussed the congruence of triangles and the conditions for congruency. When two triangles are congruent, there are four basic conditions that are necessary. We discussed the side. We also discussed about the side, angle, and the right angle, hypotenuse, and side. So, as the four major conditions for congruency. Today, we're moving on to a different lesson, and the title of today's lesson is Gradient and Y-intercept of linear functions. Okay. Um, every single one of you should be able to understand this at the end of today's lesson, to understand that linear function in the form of y equal to mx plus c represents a straight line. You should be able to identify the y-intercept and gradient of a graph, and finally calculate the gradient of a straight line. So to start this topic, you need to be introduced to the keywords. These are the keywords you'll be coming across in the course of this lesson. Gradient, mostly the gradient and the y-intercept. What is the gradient or what's the y-intercept? The gradient tells us the steepness of a line, how steep a line is. Okay, another word for gradient is slope. The gradient can be calculated by the formula changing y over changing x. And the y-intercept is the point where the graph crosses the y-axis. A linear graph is a straight line, a graph with a straight line. Now, we begin with the definition, the general equation of a straight line. What is the equation of a straight line? It is y equal to mx plus c. This is the general equation of a straight line, where the value of m tells us the gradient. M represents the gradient. And m is the gradient, and c represents the y-intercept. Now, for example, you're given an equation y equal to 3x plus 4. Now, the gradient of this line is 3 and the y-intercept is 4. Now, y-intercept, where the line crosses the y-axis at 0 and 4. It means x is 0, the coordinate point x 0 and y is 4 on the y-axis. So the y-intercept is just simply where the line crosses the y-axis. Now, let's look at this. Y equal to mx plus c. And y is equal to 3x plus 4. Now, the equation 3x plus 4. The slope in this case is 3 and the y-intercept is 4. Slope is 3, y-intercept is 4. Because c is the y-intercept, 4, and m representing the slope is 3. Now, we just let's take an example on this. Now, the first example here says find the gradient or y-intercept of these linear functions. Y equal to 3x minus 4. And the second question, y is equal to 1 over 2x plus 5. All right. From the general equation of a line which states y equal to mx plus c, of course, the gradient in this case will be equal to 3, and the y-intercept will be equal to negative 4. For the second question, the gradient is equal to 1 over 2, and the y-intercept is equal to 5. Okay, so it's your turn to try this exercise. Now I want you to answer this in your copybook. You complete the table. Okay, you give an equation and you're told to complete the missing space for the gradient and also the y-intercept. And in this case, you're given the gradient and the y-intercept, and you're expected to write the equation of the line. So you can complete this in your copybook yourself. All right. So we're going to move on to um, some of the key concepts that will be required or necessary for you to calculate the gradient of a line. Of course, I mentioned this at the beginning, that the y-intercept of a graph is the value of y when x is equal to 0. So it is the point where the graph crosses the y-axis. And I also mentioned that the gradient of a graph is a measure of the slope of the graph, which is a change in y direction over the change in x. In other words, y2 minus y1 over x2 minus x1. So there is also a very important information that you need to know about a straight line graph. Now, we've got different gradients. We've got the positive gradient, negative gradient, undefined gradient, and zero gradient. Now, if the line slopes up from the left to the right, the gradient is positive. And if the line slopes down from the left to the right, then the gradient is negative. So we're going to see all this in our next example. Let's look at this question here. There are three straight line graphs, and you're expected to find the y-intercept. Like I told you, the y-intercept is just the point where the line crosses the y-axis. The point where the line crosses the y-axis, the point where the line crosses the y-axis. So in the case of the first line, we will have y-intercept as equal to 2. That's exactly where the line crosses the y-axis. And in the case of the second graph, c is equal to 0. C equal to 0 is the point where the line crosses the y-axis. And in the case of the third line, the y-intercept is going to be negative 1, which is the point where the line crosses the y-axis. C is negative 1. So let's move on to the gradient. How do we calculate the gradient, the slope of a line? Now, it is calculated using the formula change in y over change in x, which could also mean rise over run. Now, looking at these examples, we will start by finding the gradient of each of the line below. For the first question, all you need to do is to choose 2 points on the line and draw a triangle underneath the line. So, and after doing that, we now find the change in y. This is a change in y over change in x. Now, for the change in y, we're moving how many units? Vertically? 1, 2, 3, 4, 5, 6. So this is going to be 6 units vertically. And how many units? The change in x, how many units horizontally? 1, 2, 3. So we've got 3 units vertically. So the gradient of this line is change in y over change in x will be 6 over 3. And that's equal to 2. The gradient for the first question is equal to 2. Now, let's move on to question 2. Now, change in x over... Now, question 2. Our change in y, 3 units, and our change in x, 5 units. So gradient will be equal to 3 over 5. So the gradient is 3 over 5. Now the next example, well, the next question, sorry, will be change in y over change in x. So how many units horizontally and how many units vertically? So vertically we've got 6 units, horizontally we have 3 units. So the gradient will be 6 over 3, negative 6 over 3, and that gives us negative 2. Now it's negative because the line is different from the first two examples, two questions. Question 1 and 2 is different from question 3. Now for question 3, the line slopes downwards from the top left to the bottom right. The line slopes downwards from the top left to the bottom right. And in this case, the slope will be negative. Same applies to question 4. The line slopes downward from the top left to the bottom right. And our negative will be, the gradient will be negative as well. So let's have this, changing y, choosing 2 points on the line and drawing your triangle underneath the line. Then changing y over changing x. How many units? 2 units for changing y, 3 units for changing x. So gradient will be changing y over changing x, and that is negative 2 over 3. So the gradient, the slope of question 4 is negative 2 over 3. All right, we're going to take more examples. Let's look at more examples. Now the first one is changing x over changing y, 1 unit vertically, 2 units horizontally. Horizontally, the gradient will be 1 over 2. Now, question 2, we've got choosing 2 points on the line and drawing your triangle underneath the line. So vertically, we've got 6 points. Horizontally, we've got 2 points. So our gradients will be changing x over changing y over changing x. That's negative 6 over 2, and that is equal to negative 3. Now question 3. For question 3, we've got no change. We've got no change in x, only a change in y. So in this situation, all we do is our change in y is 6 and our change in x is 0. So the gradient in this case is undefined. This type of gradient is referred to as an undefined gradient. Why? Because it's 6 over 0. 6 over 0 is undefined. Now let's move on to question number 4. Okay, in question number 4, we've got only a change in x and no change in y. So only a change in x and no change in y. So the gradient is given by 0 because no change in y over change in x, 8. And the gradient of this line is 0. The gradient is 0. All right, so we have more examples on this. Find the gradient and y-intercept of this line. I've got changing y, moving horizontally. We've got 2 over 1, and that's 2. And the y-intercept, the point where the line crosses the y-axis, as 1. All right, the equation is equal to y equal to 2x plus 1. Now, for the next question, of course, it's a negative slope or negative gradient. We've got change in x, change in y over change in x will result to -3 as a gradient, and our y-intercept will be 3. So the equation of the line is y equal to 3x plus 3. All right, it's time for you to try this question. Calculate the gradient of the line that passes through the points 1 and 3. And B, A, 1 and 3, coordinate points 1 and 3 for A, and coordinate points B, 4 and 6. So these are 2 points on the line. Are you expected to find or calculate the gradient of this line using these 2 points? So you have to label A as x1 and y1, and label B as x2 and y2. And of course, the formula for the gradient is y2 minus y1 over x2 minus x1. So step number 1, label the coordinate points as x for A, x1, y1, and for B, x2, y2. Then the gradient will be y2, change in y, y2 minus y1 over x2 minus x1. So just give this a try, please. Try this in your copybook. Okay. Um, so I just want to leave you. We come to the end of this lesson. Please don't forget to go to D6 for your activities and worksheets. Um, thank you. Thank you for your time, and enjoy the rest of your day. Thank you so much. Bye.